Hello again and welcome to 5-Minute Physics. Today's topic is sound waves, and we'll be discussing how they're formed, how they work, and how you can see them. So sound waves are really compressions and rarefactions in air. And what that is sound waves are formed by something oscillating. So in a speaker, as you have here, you would have it moving back and forth and causing pressure waves in the air. The more dense areas, here, etc., those are called compressions. They're where the particles are very close together. The rarefactions are these lighter areas here, where the particles move farther apart. So if this is the high pressure area, this would be a low pressure area, and then another high pressure area, and that's how they work. And the highest pressure areas are the wave fronts, as you can see here. So that's a very common example with speakers. Here's how you can represent that. Imagine this is another thing, another representation of compressions and rarefactions, with these being compressions, these dark purple areas, and the rarefactions being the lighter white areas. This is a sine graph that corresponds to the density of the air. The highest density here on the positive side of the graph would be the compressions, the highest density, and the rarefactions would be the lowest density areas, which can be seen here below the graph. So here you can see the cycle of moving back and forth. The compressions and rarefactions corresponds to this graph, the sine graph, moving up and down and up and down and so on. Alright, so I have another video for you guys. And this is a great example of how you can see sound waves. This is known as a Kundt's tube, this apparatus, K-U-N-D-T, Kundt. And he was a scientist who discovered this way to represent standing waves. So this person, this group, they constructed a Kundt's tube, and it's filled with, I believe it's foam pellets. And you can see that as they increase, I'll leave the volume on, so you can see that when they increase and decrease the pitch of the sound that they're playing in the tube, the pellets vibrate correspondingly. So we'll play that. And right now it's very low frequency, very deep sound, and you can see the larger wavelength there. Now it's getting a little bit louder. You can see the wavelengths are getting smaller and how the particles vibrate in place. And that's an example of a standing wave. Well, that's all. Thanks for watching, and we'll see you next time.